Hello and welcome to episode 8 in the Delphi training series brought to you by 3dbuzz.com. My name's Buzz.
And I'm Logan.
And before we get started, I'd like to remind everyone that there is a dedicated classroom over at 3dbuzz designed to provide a structured learning environment for those of you that are getting up to speed with Delphi. I'd also like to point out that if you are watching the low-resolution format of this video, you can download the high-res version from within the classroom, free of charge, of course. The link to the classroom is 3dbuzz.com/Delphi. Now, with all of that out of the way, let's go ahead and get started. In this episode, what we're going to be doing is taking a quick break from the MP3 player that we have been developing in the most recent episodes. What we're going to do is we're going to take a look at the if statement. Oh, no, the if statement. We've been using it. No, don't panic, guys. I promise you, by the end of this video, we are going to do something interesting and fun. So, don't panic. Up to this point, I know a lot of you guys have seen the if statement, like I just said, and you've probably become pretty comfortable working with it. But I have seen a few people make some posts over at 3dbuzz talking about how there has not been a dedicated lesson covering the if statement, and they feel just a little bit confused with it. And before we get much further in the Delphi training series, we need to have a dedicated lesson. So we're going to do that right now because we're about to start using the if statement like crazy in our MP3 player / music practice station application. So that's what we're going to do in this video. Take a close look at the if statement. Now, the things that are going to be covered, we are, of course, going to talk about what the if statement is and what it provides for us. We're going to show you some simple if-thens. We're going to talk about if-thens with compound statements. We're going to take a look at simple if-then-elses with and without compound statements. We're going to look at how we can nest if statements. We're going to take a look at logical operators. And finally, to the good part, we're going to write a real simple application that is going to allow, and I promise you, hours and hours of fun playing with a bouncing ball. Yeah, that's right. We're going to show you how to write an interactive application that's going to have a little bouncing ball, and it's going to allow us to demonstrate some things to you guys, such as ball velocity, bounce code, mouse interaction, and gravity implementation. So we are going to sneak some cool stuff into this video. Logan, go ahead and bring that little program up. That's a very simple application. Looks pretty boring, doesn't it? Yeah, but watch what you can do.
Well, first you can take the subject and you can grab it so you can move it around the scene.
Ooh.
If you let go of it, it starts to respond on its own and gravity pulls it to the floor where it starts to bounce.
Very nice. But it gets better.
If you look up here, we've got a mouse velocity. So we're actually recording and calculating how fast the mouse is moving. And you can use that to impart velocity onto the ball and effectively throw it around the screen.
To give it a real gentle. There you go, real gentle. Notice how you got gravity working with it, and it just kind of dampens down until it's just sitting there. Very nice. This is cool too. You got to show resizing the form.
Yeah, it's left active, so every time you change the form size, it'll continue bouncing and falling.
Very nice. And you got to show the slingshot thing.
Well, since the velocity stays active no matter where the mouse is, even outside of the form, you can take the ball and kind of shove it into the corner and slingshot it away.
That's good stuff. Love it. Now, why are we showing you how to do something like this? Well, obviously, inside we've got some very simple if-then statements. So, yes, that gave us the perfect excuse to show you how to write an application like this. But come on, guys, think past that. We've shown you, what was it, in episode 3, how you could write Flea, which was a fully functional game. We've been working on the MP3 player. We've been showing you a whole lot of things that can all be tied together with writing simple games, putting your music in there, high scores, all sorts of stuff like that. Well, think about this. Think about what we're doing here. Now we're showing you how to do things like velocity calculations, gravity implementations, etc. Stuff that can be put into some simple games. So everything we show you, each of these different episodes, we're trying to give you little tidbits that we can eventually apply to something on a much grander scale. So we will be writing this application in its fullest by the end of this video. But first, back to the not quite so exciting stuff. So let's go ahead and put that away. We will be back to it shortly. And the if statement. Let's pull up my whiteboard, Logan. All right, here we go. What is an if statement? Well, we've all seen them up to this point. An if statement is a way that we can basically make a decision within our code and we can do a branch. What do I mean by doing a branch? Well, let's say we're just cruising right along and we're executing very linear fashion, right? We execute statement after statement after statement. Then we come to a point in our program where, for whatever reason, we need to make a decision. And based on that decision, we need to do one thing or perhaps not do that one thing, but do something else. So that is where an if statement comes into play. So we could say we've executed along and now we've come to an area where we need to make a decision. And based on the outcome of the decision, the outcome is only going to be one of two ways. It's either going to be true or it's going to be false. And then we use that to our advantage. If it's true, we can start executing different things down here. Now check this out. If it's false, we could tell it to simply skip all of that stuff and jump down here and continue executing. Okay, that is one, I don't want to say one type of if, but basically ifs come in two flavors in a way.
It's one possibility.
It's one possibility with an if. You can do an if then, or you can do an if then else. This is number one. Number two is the if then else, which, let's go ahead and erase a little section right here. The if then else, what that's going to do is instead of doing these things if the outcome was false, we can have it do these things. So it's going to do one set of things or another set of things. So, there we go. Just throw that all in there. So that kind of gives you an idea. And we're going to take a look at all of this here. We're going to start really simple and start building it up. But the key thing to understand about the if-then statement is that it is a way for us to branch, and that is what we're doing right here. We're rather going straight or we're branching off and doing code over here. It's a way for us to branch in our code. So with that, we're going to start real simple. Logan, if you want to jump over real quick into Delphi, and let's just do a real simple console application.
So here's our console app, and there we go.
Let's see. Start out, again, guys, we're going to keep this really simple. So let's create a variable. We'll call it A.
So we could have A, and you want that as a number, maybe an integer?
Yeah, let's just do an integer. All right. Now, how does that work? If I wanted to compare integers and strings, they have to be of the same type for the most part, don't they?
That's a good point. If you go back to the types lesson, you see we have lots of different stuff we can use, and there's certain rules in what can and cannot be compared, because sometimes two different types can be compared if they're numbers and the way they're being compared is close enough and it makes sense.
Right.
And sometimes it doesn't make sense when you have a number compared with a text string, which is a lot of characters that don't have a numeric value.
Exactly. So at that point, it's like, huh? No, I don't think so. So in this case, of course, what we're going to be doing is a bunch of just comparisons with integers, just to make the point of how the if statement works. Now, we have set up, that's kind of scary looking. We have set up the variable A, okay? Now with A, I can do things like take A and colon equals 5. And what does that do? Well, we all know now that it creates a variable called A. And so this is the place in memory, and it puts the number 5 in it. Now, I can use an if-then to compare this against something else, some other number, and make a decision based on that. Well, how does that work? Well, that's going to get us into first the simple syntax of the if statement, which is if some sort of expression, then we have the keyword then. And then we're going to introduce some sort of statements. We're going to do something. Otherwise, why even have an if-then if you're not going to do statements? So let's first look at an expression. What is an expression? An expression is something like, let's say we wanted to check to see if A was greater than the number 5, for instance. Well, here we are. We've got an expression. A is greater than 5. This is going to evaluate to rather true or false, one or the other. Because that is how the whole if statement works in the end, is it's based off of a Boolean expression. Is it true? We're going to do this. If it's false, we can do that if we have an else in there. Okay, so with that, though, you're going to need to understand that there are a few operators that we need to be aware of. Because in doing this expression, notice right here, I've got this guy, right? So this puts us in an interesting situation where we need to know that we can do an equality test. We can do a not equals test. We can do a greater than, less than, greater than or equal to, and less than or equal to. Guys need to become familiar with these because you're going to be using these a lot in your if statements. So if I wanted to, in this case, I did a check to see if A was greater than 5. Let's say I've wanted to check to see if A was perhaps equal to 5, I would simply do a equal sign. And this might take a little bit of getting used to for some of you guys coming from the world of C, where you're used to putting equals equals to do an equality test. So Now what we want to do is a simple test. We now understand that we've got an expression and then we have statements. So we could say that we're cruising right along and we said A : equals 5. And then perhaps we want to come down and say if A is greater than 3, I'm just making some stuff up. So let's say that it is. That's going to be a true. Then we can come in here and we can just print something out on the screen. We can print true out. So very, very simple stuff. If it's a false, we're going to start out with it just being no else involved. What we'll do is we're going to simply skip like that. So this is just going to tie in and execution is going to continue going on about its business. That means that this section right here, this little, that's right out to the screen, the word true, is only going to occur if this if statement right here evaluates to true. Make sense, Logan?
Right. If we have a true condition, we'll execute an extra statement.
Right.
Otherwise, we'll skip that extra statement.
Exactly. So let's go ahead and jump over into Delphi and take all that crazy writing I just did and see if we can make it make sense. So we'll start out with simple. Let's do an assignment. We got in a variable. Let's stick something in it. So we'll put 5 in it. Now let's just say something like if A is greater than, what did I put over there? 3, I think, in the example. So if A is greater than 3, then. So we've got 2 key words then. If and then. That's required for the whole if statement to work. And we have the expression A greater than 3 in between the two. And now those get evaluated when this line gets hit and we get a true or a false back. Now we're going to perform a single statement. So let's go ahead and jump down to the next line. We don't have to do this on the next line, but it makes your code easier to understand, easier for someone else to come along and read if you kind of keep this stuff structured. Watch how Logan's going to indent it now. So we can kind of see that this indented part belongs to this if-then statement. Let's go ahead and write out the word true or anything like that. Okay. Now let's go ahead and jump down another line. And let's do another right line. Notice how Logan unindented it. So it's jumped back out there lined up with the if statement itself. And he's going to put this will always execute. Okay, so let me see if I can grab one of these mice. It's been a while since there we go, done one of these. So what we're doing is we're coming through here. We simply do an assignment. We put 5 into the variable A. Then we do a test right here. Is 5 greater than 3? Yes, it is. If the answer is true, we're going to perform this line. If the answer results to a false, then we're just going to simply skip it. No matter what, this line will always be executed. So right now, in the state of our application, when we run it, what we're going to see is the word true, and then we're going to see this will always execute. But it's going to happen so fast if we don't have a write line in there that we're not going to see it at all. So we'll throw, or a read line, We'll throw a read line in. Now let's go ahead and run it and make sure we see those 2 lines printed. And there they are. True. This will always execute. Fantastic. Now let's go ahead and close that. All right, now let's just simply change where we're assigning a 5. Let's make it a 2 or something. Now let's think about what happens before we run it. If 2 is greater than 3, is 2 greater than 3? No. So what's going to happen is we're simply going to skip this line, but this line right here is going to always execute. So in other words, we're done with the if statement. See the terminator right here? We're done with it all. We're now going to continue with regular execution. Go ahead and run it, Logan. Look at that. We no longer see the word true. We're now seeing this will always execute. So the if came, did its check. Nope. Let's go ahead and continue. That's what happened there. So that is a very simple if statement. As a matter of fact, go ahead and close that. Put did it not want to close out? Oh, that's good stuff.
Just stop it using, I wonder if it'll compile again.
Nope. It is very fun.
Let's see.
All right, well, that's all right. What we'll do is we'll just splice it right here, and we'll get rid of that for you guys. All right, guys, sorry about that. A little inconvenience thanks to the Windows start bar. It's kind of freezing up on us for some reason. But we've got it clear. Go ahead and let's close out our application now. So we can bring that back up, close it out, and we can get rid of our little messages window down there.
Wrong button. But,
okay, but it works, so we're good to go. Okay, so continuing on, this, as I said a second ago, is the most simplistic form of our if statement. Now here's the thing I really want to point out in this. You'll notice that we're only executing one statement if our expression evaluates to true? What if we needed to have multiple statements execute if the statement is true? Well, right now, let's say, Logan, go ahead and take that second right line and bring it on up and kind of make it look like it's formatted.
And let me get the tabbing over.
There you go. So, now it looks like both of those are going to execute if the expression evaluates to true. Let's go ahead and change A to a 5. So now it is true. So it's going to look like everything's working great. Let's go ahead and run it. And, true, and this will always execute. So far, so good. So let's go ahead and close that. Now, let's go ahead and put A back to 2. So now, looking at this and being inexperienced, you would think you're not going to see anything, right? Because if in your mind you're thinking that these two things, since it's formatted properly, will execute if the expression evaluates to true, well, it's going to evaluate to false, so we shouldn't see anything. But watch what happens when we execute. The word true disappears, but we still get that second line. So it doesn't matter how much white space you use or how you've got it formatted. It really comes down to the code that you're using. And what we need to do here is we need to block this out. And to do that, we'll do it with begin and end so that we can add a structure in there so that multiple things can be executed if this evaluates to true. So let's go ahead and put a begin and end, and we'll leave both of those inside.
So if that was our goal, to have these two statements be controlled by this one if, how would we go about doing that?
Exactly.
So we'll start our begin, so the start of our block, and then after the statements we can add end.
And a terminator. So now, this is the key thing here. So now we've got it set up so that we can perform a simple if statement, and if the expression evaluates to true, multiple lines, as many lines as we want to put between the begin and end will execute. Okay, so all these guys have been grouped together, if you will. They've been blocked together. So now go ahead and execute it, and this time you'll see nothing because the expression evaluated to false. So we shouldn't see anything. So let's go ahead and close that. And now let's go ahead and set A back to 5. And now if we run it, ta-da, there they both are. So now it's working properly. So now we've seen two different things. How we can set up a very simple if-then statement where we're only going to run one statement. And then we looked at how we can set up a simple if-then statement where we are blocking in multiple lines that will execute if the expression is set to true. So now what we need to do is take a look at else. And this is, if we jump back over to the whiteboard real quick, this is where I was talking about earlier, where we're coming along and we do a check, and if the answer is true, we're going to continue executing stuff. I'm just going to real quick drawing here. Otherwise, if the answer is false, this is where we're going to get into doing an else. Then we're going to come over here and we're going to execute other stuff, like such. But at some point, what's going to happen? We're going to continue executing on back down like such. Okay? Make sense?
Right. We so far have had things only happen on true. And we now want to work our way into having things happen on false.
Right. So with that, let's go ahead and jump back over to our program and see if we can code something real simple in demonstrating the execution of an else. Let's go ahead and get out the begin and end and rewrite this in such a way that it's just simple lines. So again, with a simple statement, one statement, you don't have to use the blocking.
Do you want to break this one away?
So, well, we can just keep changing on this line. So if A is greater than 3, then write true, and then let's put an else and write false.
So do a simple right line for false.
Now there's one very interesting thing here. What's the problem with this? If we compile it right now, is anything going to happen?
Yeah, we'll get an error.
We sure will. There is a terminator right now, right there, that's going to cause us some grief. That thing needs to be removed. Anytime you have an if-then-else statement, the last thing that you have right before the else where you would normally put a terminator, you do not. That's just the way their if-then-elses work. So go ahead and show them the error with that in place. So there are errors, and there we go. So terminator is not allowed before an else.
So it's one of the few errors that's in plain
English. Yeah. So we go ahead and take that out. Now we can run it. And we get true. This will always execute. Now let's go back and take a look at the code. So I'll jump in here real quick. So A is equal to 5. Is 5 greater than 3? The answer is yes. If it's yes, we're going to execute the first statement, which is what we did. We printed out true. And then, look what it did. It then skipped over all the else stuff, came down to the last terminator that's basically part of the else. So it's either going to be a terminator or you're going to have a terminator after the word end if you have multiple statements in there, which we'll see in just a second. And then we continued with regular execution. So no matter what this expression evaluates to, true or false, we're always going to execute this line right here. What were you going to say, Logan?
Right, because he's entirely outside of the whole if. Will happen regardless.
Precisely. So go ahead and take that A and assign a 2 to it, which is not greater than 3, so then we should see false, and this will always execute. And there we go. False, this will always execute. So there you guys go. A very simple else statement. Now let's go ahead and spruce this up and just add whatever you want, Logan, but let's show them what happens if we want to start doing multiple statements. Again, we need a begin and end. Let's make the example interesting. Instead of doing it to both of these, let's just pick on the else. Let's say with the else, we want to have multiple lines execute.
Okay, so we can jump down a line, and instead of having the first thing be a statement, we can have the first thing be a begin for beginning of the block. And then after the lines, place an end. And then we can place... let me get this...
format it a little bit.
Now we can place anything we want inside this block, and it will happen under the else condition.
Now this really does come down to personal preference on how you like to format stuff. Personally, for me, I like to take the begin and end when it's under an else like that, or under an if, and just kind of do them one tab over, and then their guts another tab from that. That way, when you look, you can real quickly see the if and else, and then you can
outside of the blocking?
Yeah.
So you're saying like this.
So... Yep, exactly like that. It just makes it real easy to see the whole thing. It just comes down to personal preference.
Just continues to block. Because I've seen a lot of different things, including the begin being after the else,
which is pretty
the begin
common.
being directly below the else,
yeah,
or blocking everything.
So guys, just keep in mind, it's some sort of blocking is nice though, because or indenting, because if you don't and you have lousy formatting, it's going to make it a mess reading the code later. Ooh, there's nothing worse than reading a student's code that is just every single thing is aligned to the left side.
I would say that's just unacceptable. You have to have some form of blocking. Exactly how you have the begins and ends are up to you, but ifs and things like this have to be blocked and
Precisely.
have to be indented.
So now you got the one right line. Go ahead and copy and paste that right line again and put something like...
no, really, false.
Yeah, exactly. That's perfect. So now if we run it, again, of course 2 is not greater than 3, so it's going to be false. So now we've got false, no, really, false, and this will always execute because that line always executes no matter what the condition was, true or false. All right, let's go ahead and close that out. Now, let's go ahead, and of course, we can still continue to add as many lines as we want between the begin and end. That's the beauty of having the begin and end there, to block all of this code so that it belongs to, in this particular case, the else. Let's go ahead and block the section above it so that they can actually see the end not having a terminator because of, again, that special rule.
Under the...
yeah.
Okay. So if we want to block this in, we can, again, jump down a line, tab over, put our begin, tab the statements over, and put an end in place.
And notice how when Delphi throws an end in for you, it's always awesome about putting the semicolon in there as well. You always get the terminator. But look how Delphi was intelligent enough not to put the terminator in this time because, again, what did I tell you? That last word that comes right before else, you do not have a terminator there. So if you use the begin and end blocking keywords here, remember the end does not have a terminator. Now, notice we have only one word there, or one statement. Right line, true. We don't have a terminator there at the moment. That will cause an error because that is not the last line right before the else. So now we actually have, let me grab a mouse real quick, we actually have right here and right here without terminators. This requires a terminator right here. So let's go ahead and try compiling it just to show them that we will indeed have a problem.
Well, I think because it's the last statement within a block,
it's going to let us slide through.
If we double these up, then we'll start to have a problem.
Go ahead and double it up just since we're going to have multiple things in there, but we'll say it caught me on that one. There we go. And so put the terminator up there. And I'm just going to go sit in the corner and blush. It's something that I always do. I always terminate everything except for that last word before
the rules seem to keep flip-flopping. You don't need a terminator, and then you do need a terminator, but then you don't need a terminator because there's an else, and then you do because, and so on and so forth.
Precisely. And to be honest with you, like I said a second ago, I always terminate everything except for that last word right before else. And in that you don't. And
right,
so,
it's just a good practice. If you were to copy that last line and move it to somewhere else because you were testing,
well,
all of a sudden your line wouldn't work.
Could have swore some old version of Delphi used to squawk about that.
No, it's entirely possible.
Yeah, way back in the day. And of course now I've been beaten into that habit of always have that terminator there. So
there might even be a compiler argument for it.
Yeah, possibly. But anyways, put the terminator there. You guys hear me? Okay, so here we are. We're now showing you how we can do compound statements within the begin portion of within the true portion of the if, and compound statements within the else portion of the if. And again, we can do as many lines as we want in there. So now the next thing I want us to take a quick look at is how we can go about nesting an if statement inside of an if statement. So let's say we want to do a range. And we assign A to the number 2, and then we want to say if A is greater than 1, then, and then on the next line we can say if A is less than 5. So we've established a range. Want to set something like that up real quick?
Sure. Do you want to jump down below this one?
Yeah, you can do
a new one.
That's fine.
So we can jump down, I guess after all of that.
Okay, yeah, because the execution continues.
So we can begin with if A is greater than 1, then we'll throw this under a begin.
And you can notice, again, as I started to say a second ago, actually I may have got it out, in your begin and end, you can, if you won't, get into a habit of just always do begin and end if you have one or multiple statements. And that way you're just always set up if you want to go back and add stuff.
There's no problem with putting a single statement inside of a begin and end block.
Right.
So we've done our check for if A is greater than 1. If it is in fact true, we're going to begin a block. And inside of that block, we're going to do another check. So we're going to check A again. And was that if A is less than 4?
Yeah.
So we get a range between 1 and 4?
Yeah.
So if it's less than 4, we'll do something. And you want to block this one for multiple?
If you want, yeah, go ahead and block it. But again, guys, if you're going to do a single statement, you don't have to. So now inside here, let's just go ahead and write A is between 1 and 4.
So A is 1 and 4.
All right, and now we know coming into here that A is going to be a 2, which is greater than 1 and less than 4, so we should see that line printed out. So let's go ahead and execute. And what do you know? A is between 1 and 4. Of course it is. It's a 2. So there you guys go. That is a nested if statement. And that's, you're going to be doing them often as your code becomes more complex. You get into scenarios where you're going to need to check one thing. If that thing's true, then you're going to need to turn around and check something else and then do something else. And it's called nested if statements.
Not only that, but you might run into a case where if A is 1, you always want something to happen, a statement Z to happen.
Right.
But if it's 1 and it's something else, you can have the statements nested. So that way you have this entire larger condition where lots of things might happen. But let's say out of the 3 conditions that happen when A is 1, only one of those is relevant when it's less than 4.
Right.
So you could continue nesting if statements.
Exactly. Okay, so I guess the last thing that I wanted to show real quick is talk about 2 logical operators and an or, because it will allow us to actually simplify this embedded if statement that we have right there at the end. What that allows us to do is imagine with our expression how we've been saying, let me just jump over here 1 second into my whiteboard and let me find my pen and kill everything off. In this particular case, we were looking for A being greater than 1 and A being less than 4. I mean, that's what we were looking for, right?
Right, those were the 2 checks that were done. A is greater than 1 and A is less than 4.
How convenient. So all we really need to do is this, put the word if and the word then. Ta-da, and then we just continue on like normal. Isn't that convenient? This allows us to actually employ these logical operators so that we can do, if this comparison's true and this comparison's true, and we also have an or that we can put in here where we can say if this comparison is true or this comparison is true. So how does this work from a larger picture? Because remember, in the end, the expression, the whole thing, has to evaluate to a true or a false to determine how the code down here is going to play out, right? So in this case, by using the logical operator and, this has to be true and this has to be true for the whole thing to get true. If we used an or in here, then it's this has to be true or this has to be true, and the whole thing will spit out a true.
Right, and that's the idea of the parentheses there, as we break the expressions down so that each of those expressions end up at a true or false value, and then those true and false values are compared with the logical, the and or the or.
Exactly. So let's go ahead and jump back over to Delphi real quick and demonstrate taking that last if statement that we just did and putting it in a simpler to view form using the and logical operator.
Okay, so if we started over on this if statement, we could write it as if, open parenthesis, a is greater than 1, close parenthesis, and, open paren, a is less than 4, close paren, then do whatever. In this case, we started with a begin block, and we had a write line which I'm going to simply copy and paste, and I can unindent that a block or two.
Now check this out, guys. All this up here, all that, this right here is exactly the same thing. Lot cleaner though, lot cleaner. Let's go ahead and execute it. We should see A is between 1 and 4 twice. Huh, how do you know? We see it twice. Magical here. Okay, very good. So with that out of the way, that's pretty much everything I wanted to demonstrate with simple if-thens and if-then and else statements. The biggest thing to walk away from with all of this is when you're doing the if-then-else, remember right before going to the else, when you're finishing up the true statement, no terminator. Okay, if you put a terminator there, you will have an error. The other thing I want you to walk away from this with is if you want multiple lines to execute for the true or the false condition, they must be blocked with begin and end. That will group these guys together. So that will allow you to have compound statements. Very important to keep that in mind. And we have also seen that we can come in here and we can nest if begin ends inside of if thens. And there you go. So Logan, is there anything you'd like to add to this? I know we also have the else if, but I was going to worry about that later.
The only thing I can think of adding to this is with our examples where we took this nested if statement and changed it into a logical check. There is one advantage to this method. It's not, the result in our case is the exact same thing because of the way we have it set up. Since we don't have anything outside of this if, we only have one possible thing that can be done. What you can do with the nesting stuff is we could add a statement in between these two.
True.
So we could have added another write line. So a write line that always happens if A is 1, even if it's greater than 4.
Exactly.
And so on. So you could have more control if you wanted. If you were only checking for a range, then you would definitely want to go with the logical method.
Beautiful. Okay, that is everything that we wanted to show you guys for the if-then and if-then-else statements. So now, let's write a program.
All right, let's do it.
Get on to some fun stuff.
We're done with these tests, so I'm going to close them all out.
Okay.
And we're going to begin a new program, and this one will be a VCL Forms app this time around.
Okay.
So here we've got our simple form, and we need to start adding all of our elements. So again, this is going to be the bouncing ball example that we were showing earlier. So the first thing we'll need is the
bouncing ball
visual component of the bouncing ball, which in our case is going to be a shape.
And let me kind of just throw a couple things out there while Logan puts up a shape. First of all, no 3D real bouncing balls. We're not worried about rendering at the moment, so if you get flickering and stuff like that, that's not the focus of this lesson. The focus is, of course, just the if statement. Now we're getting a little bit fancier and employing just a couple if statements in a more complex application, but I do want to point out that we could, of course, write the whole rendering engine way different than we're doing here, so that it's flicker free. We could handle the looping the way we're going to do it in just a second. We're going to use a timer. Of course, there are other ways that we can employ a game loop, if you will, to handle our render updates. We could do it in a much different way, but it requires some lectures that we've yet to provide them.
Right, it's an entirely different ballgame at that point. It's a different architecture that you have to start thinking with.
So I'm throwing that out there just as a reminder to you guys. For those of you that are playing around making your own really simple games right now, I think that is so awesome. I can't tell you guys how excited I get when I get on 3D Buzz and I see that someone has published a new game. Believe it or not, since there hasn't been that many, I think I've checked out every single one that's been put up. And there's been a few times that I've actually grabbed Logan and Zach and Terry, told them, hey guys, you guys got to check this out. It's really cool. So I do see those games. But in this particular case, now we're starting to get a little bit more fancy with the things we're doing. I just want to point out that we're not quite to the point yet where we're showing you how to really go about game rendering. We're still keeping things at a very simplistic level, both for the rendering and, of course, for the game loop itself by, in our case, just using a timer. So I just wanted to throw that out. Right.
We're just doing some updating and calculations. For the drawing, we're just leveraging the fact that if you happen to move a Delphi shape around, it redraws itself.
That's right.
Kind of convenient.
So you did a simple shape, and you set the width and the height to 32 by 32. Good. And you change it over to a circle.
Right, just for the theme of a bouncing ball and make a round thing.
So we need a ball and we need a timer. We need something that's going to just keep updating.
So jumping down to system, which I've passed, we can drop a timer down, and I'm going to set the timer's interval to 16. I'm setting it to 16 because that will give us roughly 60 updates a second, which will be nice and smooth.
Let's want to throw that label up there real quick just to show them, so we can run it.
Because, I mean, this timer is active now, so if we build, we'll have a running timer. And to look at that, what I mean by the 60 updates a second, we could drop down a label up at the very top, a line like so. And we can have it set up so that when since we can't change the timer live, I'm just going to have it calculate this on app load instead of at every timer interval, because that would just be unnecessary.
Yeah.
So if we jump into the forms create, we can run this calculation for the label.
What Logan just said, for anybody who didn't follow him, is there's no reason every single time that timer fires for us to update this caption, because we are not planning on changing the interval of the timer while the application is running. We're setting it right here at the beginning, as we've already done. And so when the form is created, as you can see in the form create event that he's putting in right now, basically when it starts up, we're just going to populate this information, and it's going to stay there because the timer, again, is not changing. But look how he's doing this. He's, let's go ahead and hit home real quick for me. He's starting out by saying label1.caption. Of course, you guys know, make sure you name your objects. We're just kind of being quick here. So label1.caption equals, and he's using the format function where he then can come in there and provide a string. So here we got update / per sec. So how many updates per second? And you'll notice he's providing it a %.1f. Ooh, what is that, Logan?
Well, if we had given it just %f, we're telling it to format a float for us. Mm-hmm. But that float would probably default to 2 decimal places in its display, and I only wanted 1 decimal place, so I specified that with .1.
Okay. And then the comma. Now, what is the float that's actually going to be put in there? Now that he's got the formatting in place, what are we going to hand to it? And so what he's doing is 1,000 divided by the timer1.interval, so the interval that he just set a second ago.
So for this interval, how many updates will we get in 1 second of time? Since the interval is in milliseconds, we have 1,000 milliseconds to represent a second. So how many updates per second? So if we run this now, there you go. We're running, you can basically say we've got 62, our frame rate is 62.5. Right. And the reason I can't tune it to exactly 60 is because the timer's granularity is in milliseconds. We can't get to a sub or less than 1 millisecond or a fraction of a millisecond. Exactly. So you'll end up at what, like 58 or something like that if you try? Right. You could jump between about 58 and about 62. Gotcha. Okay, cool. So we'll just leave that in place. Very nice. Now we need to see a ball move around, right? So we've got a timer in place, and we know that thing's firing 62.5 times per second. We've got a ball that's just sitting there. Now we're going to need some attributes, some variables that are in play where we know the ball's position, x, y, and then we're going to need to start worrying about its velocity as well, because in this particular case, the ball can move around, and it's going to need a velocity since we're going to start employing gravity and things like that. Right. This gets a little bit more complicated than some of our original games in that instead of doing updates based on time, we're doing updates based on velocity over time. Yeah. And to make this more convenient and readable, we're going to set up variables that represent object and scene attributes. And on some of those are going to be the 4 things we need to represent the ball. We need a position for the ball and a velocity for the ball. So the position will be position x and position y, since all of this is just 2-dimensional. And we're also going to have a velocity in x and a velocity in y. All of these are going to be of type single, so a single precision floating point, or allowing us decimal accuracy. Not an incredible amount of accuracy. I didn't go for a double.
And why not? This is easy. Tell them.
Well, this is very simple. I mean, we could probably get away with 1/10 of a pixel per update. The whole reason I'm doing a float, though, is so that the ball can move less than a pixel in an update. If we did everything with integer, which might seem to make sense since everything in the form is an integer.
Right.
The problem is we could have the ball moving so slow that it doesn't actually manage to move a pixel. If everything was integer and it did manage to move, it would just stop at that point, even though it had some residual velocity.
Right.
If we do all these calculations as floating point, we can move less than a pixel. We won't see it move for that update, but it will eventually move enough to cross over to the next pixel.
Exactly. Now let's go ahead and add a comment right before that. Let's call these ball attributes.
Good idea.
Now you'll notice we are basically making global variables that can be felt all throughout this unit here.
Right, since the idea of the ball is that the ball is an object that transcends each of the individual procedures, so we need these in global scopes, so that they stay alive outside of the procedures.
You got it. All right,
so we got some ball attributes, so we should be able to hook them up and use them to move the ball around the scene. And this is where the core procedure is going to be required. We need a procedure that takes into account velocities and applies them to position, and then turns around and takes these positions and applies them to the shape, because these positions are just arbitrary variables. They have no link to the shape yet.
So we'll have a procedure called update ball, because that, well, makes sense.
So we'll have our update ball procedure, and Control-Shift-C will fill that in for us. Now, inside of here, we need to take our current position and update it by whatever velocity is currently currently set. So we can take our position x and set it to equal position x plus velocity in x. So if our position is 1 and our velocity is 1, our ending position after this will be a position of 2.
Exactly.
And then it'll continue adding whatever happens to be in velocity. And we need to do the same thing for y. So position y is equal to position y plus velocity y. And once we have all this set up, we need to turn around and apply our position in x and y over to the shape. Exactly. So we can say shape1 dot left is equal to position x. But we can't directly use position x since it's a float, or well, in this case, a single.
Right.
So if we tried to put position x into shape1 dot left, we get an error because they are incompatible types. So we need to convert this float over to an integer. Now, I want to keep this as accurate as possible, so we'll round to the nearest integer using the round function. So we can round position x over to an integer and store that in the shape's left. And then do the same thing for top. So top is being represented here by y. So we'll round position y into the shape's top.
So as soon as we get over that 0.5 spot, we're going to move over that pixel, basically.
Right. That's just how we're going to round for accuracy here. Since obviously we can't represent 5.5 in pixels, we don't have half pixels or anti-aliasing.
Right. So now we just need to set some velocity and.
Yeah, so, well, for our initial stuff, it would be a good idea to initialize the variables anyway. So up in the form create section, I'm going to initialize everything we've got. So we can set our position x to 0, our position y to 0, our velocity x, we can set that to 1. And our velocity y, leave that 0 for now.
Okay.
So positions and velocities and the timer. Okay, so here's the last thing. We have our update ball that is not tied into anything. We need to jump back to the timer.
So if we run it at the moment, the ball is just going to sit there.
Right.
Yep.
Because there's no link between
but
the timer and the update.
Remember, that timer's firing 62.5 times a second. So now we just need to tell it to update the ball every single time the timer fires.
So one simple call to update ball should achieve that. So we run, and now we have a moving object. So we've got animation going on in the scene, and as soon as we hit the edge, we just go off into space.
Exactly.
So now we need to get some more
and we could, real quickly, let's just go ahead and take our velocity for y. Let's put a number on there, and you'll see that it'll, like if we do a 1 there, we're going to start going, or 2, yeah, that's good. We'll start going at a sharper angle. Yeah, there we go. And again, off the screen. Yay! So now we're ready to some bounce code?
Yeah, we need to detect the bounce condition. That is a condition where the object has left the screen, and instead of leaving the screen, instead needs to reflect off of the edge that it hit.
Okay. Before we do this, do we want to throw up any ball velocity information on the screen?
Sure, just keep a running tally of how fast the ball's going.
Sure.
So we could grab our label, make a new label, just as somewhere to hold or somewhere to display this information. So We'll have a second label, and yes, I'm leaving everything on the design phase very dirty and unnamed. That's because on all of this I'm focusing on the internal engine pieces. We've got things like our velocity named, and we'll just let Delphi render the rest of it on its own time.
But you guys know to use real names, right? Right. Good.
Now, unlike the update to second, this is more of a live attribute than a static one. The velocity can and should change if we in fact get this program finished.
Precisely.
So we need to update our displays as the actual velocity updates. So I'm going to set this, let's see, before we set the position. So coming in, we haven't modified velocity at this point, so we can do that as the first thing we do when we go in to update the ball. We can tell it to update our display, and I might actually just steal our last one because then I'll have a skeleton format line I can run from. So we could say that here we have ball velocity.
Now he's going to actually represent two floats. You can just do %F with a comma in there. Oh, you need that F. So that means you need to make sure you hand it two floats out there that you can.
So over here we have the first F will be velocity X, and our second will be velocity Y.
And you guys, hopefully by now, are starting to get kind of a hang of how this format function works. Basically, everything lines up, almost like when you're calling a procedure and you're passing arguments. First argument into the first line, etc.
Multiple arguments set up in these brackets, comma delimited, and they go in order. Yes, there are ways of changing the index from here, so we could have like velocity Y appear first, but that gets more complicated. Just for something simple like this, it's just easier to align them yourself. So we're first and second. So we have X is first, Y is second.
There you go.
They get placed here.
All right.
And label, I'm setting the wrong label, aren't I? We need label 2. And there we have our ball's velocity.
Perfect.
So that will become useful if we need to debug things like velocity changes because of things like ricochets or gravity. But with that in place now, let's move our attention over to ricochets. So after we've set our position...
To get you started on that, the very first thing we're going to want to do is be aware of the width of the ball, because we're going to need that in a minute.
Or, yeah, that'll be... Just keep that in a more convenient, easy-to-use format.
Yeah, I mean, obviously we could at any time say the shape1.width, but this will make things a little bit easier by just having an attribute called like width or something, or ball width.
Ball width.
Yeah.
So ball width is going to be an integer because ball width is representing that shape, and shape's dimensions have to be an integer.
And
so we've got our ball width.
Initialize it.
Now, we need to initialize it, and we'll set it to whatever has been set up within the IDE. So we'll say that our ball width is equal to shape1.width.
And we'll just use this for both width and height, because with the program our goal is obviously to keep it 32 by 32, or basically some square number.
Right. That the object is all, we'll just assume that it's square in this case, and then we'll have fewer attributes we have to track. So we have a width that we can use, and the width is important because if you have the ball going over to the right side of the screen, if you used only position X and Y, that's position X and Y calculated at the top left.
Well, bring up Photoshop for me real quick.
Sure.
Just to show you what he's talking about. Let's say we're looking for a bounce, and here is the bottom right corner, right? And so we have our ball. That is, it's a shape, right? It's inside the square area. But here's what we're looking at. So this is what we're going to be comparing for our top and for our left. And obviously, when the ball starts to hit the side over here, we wouldn't really know that it hit, right? Because we're looking right here. If we didn't take into account the width of the ball. So we need to take into account for the width when we're looking for this side of the screen over here, so that we know when we do indeed have contact.
Otherwise, it would look like the ball slips off the edge of the screen and then rebounds.
Yeah, once this dot right here, once the whole thing, basically picture this box sliding all the way over so that it is right here. Then we'd have contact, and then it would start coming back. And the same thing's also going to apply for when we're going down as well, because, well, top's all the way up here. So by the time it gets down here and notices that there is indeed contact, where's the rest of it at? Ball's off the screen. So we got to take that into account.
So jumping back over now, we'll do these checks right after we've assigned the position, because we need to have the position updated first. After we've set our new position, we'll check that position to see if it has caused a ricochet. So let's check horizontally first. So we can begin by checking position X. So we'll say that if position X is greater than, we'll use client width and client height as the area we're checking, because that's the usable area inside the app, ignoring things like the borders and the title bar. So we'll say that if the position X is greater than...
That's built in, by the way.
Client width, and if you're wondering where this variable comes from, it's actually part of the form. So we could say form1, I'll just show this, form1 dot, there we go, client width, client height. So that's where I'm getting those from. The reason I can use them is they're in scope right now. We're looking at a procedure belonging to form1, so I can just use it without having to specify form1.
Of course, you could still type out form1 dot. I mean, that's...
Right, it wouldn't cause a problem.
Right.
So if the position is greater than the client width, but this left alone will cause that problem we've just drawn on the whiteboard. The ball goes off the screen and then comes back. So we have to take into account ball width. So we will subtract ball width from the client height, thereby giving our offset so that we bounce from the right side of the ball instead of the left side. So if we have in fact ricocheted, then we need to begin and do something to reflect the ricochet, change our direction, and whatever else we need to do. So I'll jump down, I'll start at begin, and we'll let it fill in an end as well. So inside of this begin, what do we need to do? Well, if it is greater than, that actually means it's a little bit off the screen.
It went 1 pixel past.
So we need to reset it. Otherwise, if you catch the update just right or your computer's slow, you'll actually see it disappear for just a second.
Yeah, let me update what I just said. You could be 1 pixel past. You could be several pixels past, depending on the velocity from the last update. So this way, what Logan's about to do is he's going to forcefully reset it so that it doesn't look like it goes off the screen.
Yeah, this will simply snap us back to the edge we need to be on. So we can say that our position X is equal to the client width with the offset in place. So this will snap it to the right side edge in X.
Right.
Now, we need to have a ricochet takes place, and we're going to describe a ricochet by reversing the velocity. So if we have positive velocity in X, then this condition will probably occur eventually. And once this occurs, we need to start going the other way. So we can simply reverse X, and that will reverse the direction of the ball and look like a bounce. So I could say velocity X is equal to negative velocity X.
It really is that simple, guys.
So to test this, I could just go and change the velocity so that X hits first and we don't have the ball going off the screen so fast. And watch the ball.
Ooh.
And a bounce.
Very nice.
And now we have 3 other directions to account for.
Yep.
So that takes care of that. Now, we can do this staged as an else here because we're never going to have a case where the ball will be off the right side of the screen and off the left side of the screen at the same time. If you do, I'm sure there's some quantum mechanics people that would like to talk to you. So, in this case, we need to start
an else. Notice how he just killed that Terminator out.
Alright, so we don't have any compiling problems. And then we'll begin. As a matter of fact, I'll just copy this because it's the same idea. Though we need to, inside of this block, we probably need to do a check because we don't want to always bounce off the other side. So I know you didn't cover if else, but I'm going to put an else after.
Well, it's really simple, I mean.
So else, if, and then I can more or less just copy this.
I think you guys can figure out the else if. Da-da, there it is.
So now we're on the other side, though. So we're not greater than the client width. We're less than, and we're not less than the client width. We're actually just less than 0 because 0 is the left side.
That's right.
So if our position has gone less than 0, we're off the left side of the window. And we need to reverse our velocity, so that can be left alone. But our position needs to be set to 0 to snap us back to that edge. So now I don't think I've terminated something, probably this end. That would be a good candidate for problems. And there we go. Bounce, good. Bounce, very good. And off the screen.
Nice.
So we can take this entire assembly we've put together with if statements, copy the entire thing, paste it in place, and adjust it for vertical checks. Mixed up for a second. And we can do that by more or less changing every occurrence of X to Y and every occurrence of width to height. So I guess we'll just take a second to go through and change all of these out. So position-wise, velocity-wise, position-wise, and so on. And then one last check for client height instead of width.
This is where you would need to be careful if you decided to have an object that was not square. You'd want to make sure that you took into account the ball's height here.
Right. If we had a ball height to represent a different height, then we'd need to do that. Otherwise, you get some funky results. A ball that would bounce without colliding or go through stuff.
Right.
So, unless I'm missing a variable, that should work.
That looks
So
good to
we'll do
me.
a check. Got our bounce. Second bounce. Bounce off the bottom, and I'll let it play out and we can check the top. And there we go.
Very nice.
So we have 4 side bouncing on the object, and it'll just continue at its current velocity for the rest of eternity.
You'll notice if Logan
sides.
resizes the form, since it is indeed taking into account the space, the client space, both width and height, that, oh, how convenient was that? That's cool. That it works as Logan is indeed updating the size of the form. Very cool.
So really not all that much of a stretch. It's almost exactly like the if statement lesson with a little bit of nesting, and we've got a ball that ricochets around a form.
Now we can get a bit more complicated. We can throw the mouse in there. Let's get some interaction going.
Yeah, the interaction is always fun. It's the basis of games.
Well, I promised hours of fun and play with the ball, so we need interaction.
I mean, this could be hours of fun for your cat because it's not realizing that it's not catching the ball, but for it to be fun for a person to play, we need to put some interaction in, and we'll go with mouse interaction. So, what kind of interaction do we want? Well, just like the example program, we want to be able to pick up the ball and move it anywhere on the screen. Then we want to be able to release it, or, if we choose, throw it.
Right.
Now, the throwing is where the trick comes in. If we were just doing grab and release, that's very simple. 2 quick procedures and then stopping and restarting the ball. Mm-hmm. Easy. Now, what we want to do is we want the ability to throw it. Throwing means we have to impart velocity to it. And the velocity, to make it look like a throw, has to be based on how fast the mouse is going. So we're going to have to look at where the mouse is at and calculate its velocity.
Right.
We don't have mouse velocity just presented to us. We have mouse position. So we're going to have to turn position over time into a velocity value.
So we need some new attributes.
We need some new attributes, and we'll need a new procedure. So let's put the attributes down. Let's start recording some mouse attributes. So mouse attributes go here.
We're going to want things like last mouse X and last mouse Y, because we need to know where they were the last update.
Right, this is going to be the basis of our speed calculation.
Right.
We'll take a look at where the mouse is right now and where the mouse was last time we checked it. The distance between the two will be our velocity.
You got it.
And let's see, both of these are integers. Yeah.
Now we'll need our mouse velocity X and mouse velocity Y.
It's mouse vel X, mouse vel Y. And we'll store those as integers as well.
And then finally, we're going to need to know if the mouse button is down or not. Right,
that's going to be key for grabbing something and letting it go, because as long as it's held, it needs to stay with the mouse.
Yeah, because that ball update's constantly firing 62.5 times a second. We need to know if that mouse button's down so that we don't keep moving the ball around.
Was that mouse button down?
Yeah.
And that will be a simple Boolean. Alright, so those are our mouse attributes. And now we need a procedure that can calculate the velocity based on those positions and last positions. So I'll make a new procedure, and we'll call this calc mouse velocity. And we'll fill it in. Now, some of the things we need to do here. We need to check the current mouse's position on the screen, but the way we need to check that has to be relevant to the screen itself, because what we're going to use is the mouse object that exists with any VCL app.
Right.
And that gives us access to a cursor position. That cursor position is in screen space, meaning 0, 0 is up in the top left corner of the screen, and then you have the bottom left based on however you have your resolution
He's not talking
set.
about of your application.
So this is going to...
The screen.
Yeah, and we need to be able to calculate from within the screen itself. Because, I mean, we could technically do the velocity based on the entire screen, but we wouldn't be able to do dragging, because we drag the ball here, and we'd see the ball move with that much of an offset.
Right.
So we need to store some properties, some local variables in here, so that we can keep a track on exactly what we're doing.
Okay.
And I'm just sifting through stuff here to get a set. What we need to track inside of what we need to track locally is our current mouse X and mouse Y. And the reason I'm setting those as our own variables instead of using the mouse one is, again, we're going to calculate an offset based on a different origin. And if we had to do that calculation over and over again, it'd be cumbersome. So we have a mouse x and a mouse y that we're going to set here, both integers. And yeah, that's right. And now we need to set those and get that offset. So what we're going to be...
Go ahead and actually throw the comment in there. Compensate for window origin versus screen origin. I'm going to have Logan watch the comments in this area here just in case this gets a little bit technical for some of you guys. So for window origin versus screen origin. All right, so let's go ahead and throw it in real quick.
So we've got let's set our mouse x first. And that will be equal to mouse. Remember the mouse object. Inside of that we have cursor position as a point. And inside that point we can access elements like x and y. So x for mouse x. Now again, here is our screen-based origin. Now we need to offset that based on the actual client. And before we were using things like client height and client width. Well, we have something else we can use. We have client origin. And if I'll spell this out in a long form, but then I'm going to shorten it down to just the variable.
Now, when he's talking about the client origin, he's actually talking about our application now.
Right. So form1 dot... Okay, it's not wanting to give...
Let's do self dot.
I don't know if self is going to work because... Well, hang on. Let me do a minus here first. See, it was still taking this as all into account.
One part thing.
So self or form1 dot... We have here client origin. So that gives us our offset for how far the client origin is offset from the screen.
Okay. So and then, of course, we need to go inside that and grab the dot x.
Because, again, that's a point, and we're calculating like so. So if we take our mouse position...
And again, you'll notice you just ripped the form 1 out. Again, it's because we're within the procedure T form 1 we have.
And in the scope, it's redundant. Yep. So, confused yet? I know I am. But anyway, we'll copy that line, throw y in, and now we'll have both x and y. So we have mouse x as you can think of as a local, not only to the procedure, but a mouse position within the form.
Let me simplify this. He's just calculating the offset, so we don't have a big offset between the ball and your mouse.
Right, because otherwise it just wouldn't make sense. You'd have to move your mouse outside of the application into imaginary space and move the ball around.
Okay.
So we've got our mouse x and our mouse y. Now, let's say, we need to calculate some stuff. I was looking too far ahead. We need to calculate how much the mouse has moved because we have a current position, and earlier we had set up to have a last position, and any difference between those two is going to be our velocity.
Okay.
So we can set up our...
You're going to do last or you're going to do velocity? So we need to do last first. So just go ahead and tell the last mouse x is currently...
Right, it won't make sense unless we have that first.
Right, you have to.
Of our last mouse x...
Just so you guys know what was happening there, Logan wanted to jump ahead for velocity. I saw where those eyes went. So it's just going to set it to mouse x at the moment. It'll make more sense in a second, but go ahead and just set it.
Mouse velocity. Yeah, I'll get this set. I'll put a comment here for saying...
set velocity.
Difference calc here.
Okay. You guys will see. This will make sense in a second to y'all and to Logan. So just go ahead and set mouse x. And then same thing for y.
So our mouse y, like so.
So now we can do some work between the two lines that he has above and the two lines he just did there, where he's got the comment difference calc here, because in there we're going to have as a matter of fact, if you don't mind, let me grab a mouse real quick. In this area right here, once we've run through this the first time through, now we've got mouse x and mouse y is going to contain something different than the last mouse x and last mouse y. This contains our new mouse x and y, while this is holding our last, and now we can do some calculations with that to come up with velocity and all.
Right. The comment was left, though, because the order in which this is done is very important. Between these lines is the only case where mouse x and last mouse can be different.
That's right.
Anywhere else, like if we had put something below it, we have just set them to be equal, so it didn't matter if there was a difference. It would have been nullified by that point.
Exactly. So now it's really simple. If we wanted to calculate the velocity x and velocity y, all we do is just take mouse x and subtract the last mouse x, and now we've got our mouse velocity for x.
So we can set our mouse, again, these are the attributes we had set before. So we're working on mouse velocity x. So mouse velocity x is equal to our mouse x minus last mouse x.
And that's it.
And then we can copy that line, and that gives us our y velocity as well. And there we go. So we have our velocities in place.
Now we can go ahead and show our mouse velocity so we can make sure that it's actually working. We can test it real quick.
See, I'll probably need another label to do that. So duplicate one of these labels and move it about like so. So this is label 3. And it will have a caption of some formatted text. So format. I could copy it, but it's too far away now.
That's great.
So
I've got
this
a
is our
scroll.
mouse
velocity,
and that is 2 floats, %f and %f. Or is it going to be integers?
No, it's going to be integers.
Oh, right. Okay, just used to. Maybe I should have looked somewhere else. So instead of %f, %d, representing integer, and then we're good. So
and then we just need to give it mouse velocity x, mouse velocity y.
Finish off all the format stuff, and then inside of here we have mouse velocity x and mouse velocity y.
So now the cool thing is we can actually test this out and just make sure that we actually see that caption updating showing mouse velocity.
Though I don't think we
need to call that, of course.
So if I jump down to the timer, we'll calculate the mouse velocity before we update the ball, since velocity is going to have bearing on the ball's position. So, compile, run, and as I move the mouse around, you can see these numbers changing. So, looking at x first, move to the right, positive numbers. Move to the left, negative numbers, which is correct. Positive, increasing the shape's top is going to make it move this way. And then same for y, down, positive, up, negative.
And now here's the biggie. All the complicated looking stuff we did a second ago, move your mouse out somewhere else on the screen. Notice how it's still calculating way out there. It's not like we used a mouse move event that's inside the form, where you actually grab and hold that mouse object.
Right. The cool thing about that is this velocity is based on the time between the timer updates, which is the same time between the ball's updates, which means that the perceived velocity of the mouse should carry directly over to the ball. So that's kind of cool. And we're done with that, so we can kill this out. Now, to go about using that velocity, well, to use it, we'd have to be able to pick the ball up to be able to throw it, so I think we're going to have to start looking at things like mouse down and mouse up.
Agreed.
So we need to have a mouse down that'll do things like mark the fact that we're holding the ball.
Right.
So we'll grab our form, we'll go down to events, down to input, to which I just scanned by. We have our on mouse down. So let's start an event there. And the first thing we need to do is remember that if the mouse is down, that we set our mouse down variable.
Right.
So mouse button
nothing. Woohoo!
Down is equal to true. We've pressed the mouse down, and until we release it,
and again, this is going to become very important, because when we do update ball, we're going to need to check, is the mouse button down?
So since mouse up and down go hand in hand, I'm going to go ahead and set in our mouse, or our on mouse up event, which begins with mouse button down is false.
Actually, there's no reason to check if it's down in that one area. We just set its velocity to 0.
And so that
backing the mouse down.
So if it's moving, in order to make it stick to the mouse, we don't want to have residual velocity. So we pick it up, but then it starts to move away from our mouse. That would defeat the purpose of picking it up.
So we just stop it. Yeah, just set the velocity to 0.
So we stop the ball, and now if we compile here, that should stop the ball, but nothing happens. We're not dragging it.
Right.
So what we need to do is, whenever we have the button down, we need to just set the ball's position over to the mouse, and then that will visually look like we're dragging it.
So instead of doing it in ball update, we can do it where we're calculating the mouse velocity.
Right. So as we're calculating velocity, we can say that, matter of fact, we want to jump down probably after the last velocity set.
Yeah, we can just simply say that if the mouse button's down, then we set position X and Y to whatever the mouse is, basically.
So we'll start at the beginning, because we need to do two different statements for the velocity. And we'll say that our position, because if we set
exactly, position X
is equal to wherever our mouse X is, and we have that nice conveniently calculated and offset value that we work so hard for. And right, if there is an extra offset we'll have to add, because if we set it directly like this, you'll see, all right, we can stop the mouse, and it snapped.
Yep.
And it moves as long as we have the button down, but the offset's wrong.
Remember the little picture I showed you guys back up? Go to Photoshop real quick. Remember that? Remember that? Hang on, let me grab a pen right here. Remember that little corner? All right, remember that? Now run the program again, Logan. Think you still have it up? Now click on it. Ah, look where we're at. So we need to count an offset to figure out halfway over and halfway down. Think all the way back to the days of Flea. We had to do that in Flea too, when you clicked and drug around. So it's just going to take the shape's width and divide it by 2 and the shape's height and divide it by 2.
So that means we need some offsets. So we'll subtract. I wonder if we could just do ball. Yeah, I'll do the shape. Shape 1 dot width divided by. As a matter of fact, I could do divide by 2. Notice I'm doing floating point division instead of integer because so far everything's calculated as a floating point. We might as well keep the accuracy for now and wait until we convert it to the shape in order to actually get our final accuracy. And
do our height.
Height might a little bit
you can still do
with.
Yeah. Same, I mean, it doesn't matter in this case again because we've stipulated that.
And
we're
what I was
square.
tripping myself up on is the fact that we could have used ball width.
Yeah.
Since they're all the same in this case, it would have all resulted in the same visual effect. So now if we grab our ball, we have the ball centered on the mouse, and everything looks a lot better.
Nice.
So we've got the ability to mouse down. So our mouse down is working since we now have this logged as dragging. We can see that because the position updates with the mouse. Mm-hmm. And we can release it. As soon as we release it, mouse button down is false, and we are no longer dragging it. The only thing left is to take this velocity, which we have calculated, and impart that into the ball. Because here if I try to throw it, nothing happens. As soon as you release it, you get nothing. So we need to set it up so that the velocity gets imparted into the ball. And we can do this as soon as we do our mouse.
Yep, up. Just mouse up. Yep, real quick and simple, actually.
So jumping down to for mouse up, we've recorded that we're no longer holding the ball, and we need to impart some velocity. And this is why mouse velocity X and Y are global, so that we have them available here in a different procedure.
Exactly.
So we can set our velocity X to equal mouse velocity X and velocity Y to mouse velocity Y.
That's all.
So, grab the ball, stop it from moving, throw it and release it, and now we have a lot of velocity imparted, or a little bit of velocity imparted.
Very nice.
And everything picking up, because if you watch the mouse carefully, and then it pretty much picks up exactly what you left it at.
Go ahead and do a bring to front on that ball, just so it's over all of our labels.
Do a bring to, let's see. I'm going to do a few tweaks, because I just noticed another problem. You see, we have perfect dragging ability.
Yep.
Unless the mouse is over the ball to begin with, you mouse down, and it doesn't pick the ball up.
Right.
This is because that shape is receiving mouse down events.
And we have nothing there, so you're just going to disable it?
Right. If we disable it, then that event will drop through to the form, and everything will work as it should. So we can just mark that as enabled to false.
Another thing we had to do in Flea.
Now for these labels, I don't mind them drawing over. I do mind the fact that they have the gray solid background. So I'm going to select all of them, go to miscellaneous, and tell them that they're transparent.
Okay, that'll look better.
So we still get the text overlay.
But that, it looks better.
But yeah, we don't have the big gray box draw effect.
Cool.
So there we go. And if I move the mouse over the ball to begin with, click down, and I can still grab it.
All right. So some gravity now?
Some gravity sounds great. Let's see. For gravity, what does gravity actually do in our case? Well,
it's going to modify our velocity.
Modifies our velocity, but only in X. We need something that...
Only in Y.
Oh, yeah, exactly. I was thinking one step ahead. Again. Okay. So we need to modify velocity Y, and we need to make it so that the ball always tends to go down.
Right.
So we need to have... Let's look back at the game for a second, or the program. So velocity down is positive Y. So that means we need to add some positive Y to the ball every time we update, and it'll look like gravity is pulling it and causing it to accelerate downward.
Exactly.
Now, to make the application of gravity easier here, I'm actually going to make a procedure called apply gravity so that if this gets complicated or more than one line, we don't have to worry about this messing up our update ball procedure.
Okay.
So I'll make a procedure called apply gravity. And
let's go ahead and give an attribute to keep track of our gravity.
Right, what the current gravity is. And so we can add a new section, and we'll just
call it scene attributes, and it'll be called gravity, and it'll just be a single.
All right, scene attributes, gravity, single.
Okay.
And no, this isn't going to equate to actual gravity or what Earth's gravity or any other kind of gravity should be. Really, all this is the value that gets applied to it every update.
That's right.
So, under apply gravity...
Which, speaking of that, we can go ahead and have a little bit of fun real quick. Just jump on down to the update ball section and go ahead and call apply gravity. So they'll see that every time that timer, there we go, every time that timer calls update ball, we're going to turn around and tell it, all right, apply gravity first, then let's start working with our new velocity to have it affect our position.
And like you said, I'm going to do that as the very first thing in update ball. Since we're using velocity here, we're showing it in our display system, and then we're using it for position.
Right.
So we want to make sure we have the most current gravity or most current velocity before we continue with this stuff.
Exactly.
So to begin with, we'll start with
just
an
tell
apply.
It to apply gravity.
And not caps lock. There we go.
Okay. Now we can code it in. As soon as we go to test, we know it's going to work because we didn't forget to go down and put the call in.
And while we're cleaning things up, we might as well go and initialize gravity as well.
Sounds good.
So back up to the form create, and we'll say gravity is equal to...
Equal to 1 for starters.
That sounds good.
Just
Simple.
as needed, yeah.
So we've got gravity set to 1. Our update calls the apply gravity, so now it's just setting velocity inside of apply gravity. So we're working with velocity y. We know that's the one we want to affect. And we want it to increment or decrement, so we'll say velocity y is equal to velocity y plus some value. And I'm using plus because we want gravity to go down.
Right.
So we'll add the gravity value, or the gravity attribute.
Now there is one interesting thing we need to do in here. Since we're not taking into account inside ball update if the mouse button is down or not down, because we just set the velocity to 0, we need to go ahead and check and apply gravity. Is the mouse button down?
Because let's see.
Because
I almost want to show it with
that's cool.
Not added first. So, well, so far so well. Is it? I think I might need to multiply it by a factor because if it's going...
Oh, it's going to stay the same. You're just not dampening it off by... You see what I'm saying? Like if you got...
Oh, we're reflecting it. Okay, I see what you're saying. So it's... Yeah, I was looking for the wrong thing. This is, in fact, different. It wasn't bouncing just a second ago.
Exactly.
See, I've just been staring at this app too long.
It's just right now you've got
a
perfect bounce going on.
So we've got our balance and our gravity set. It's just not decaying.
Right.
So far, so good. And I can test what I was going to. Grab the ball. Wait, no, grab... Wait,
it's like a yo-yo.
And it always slides away from your grip. And that's because gravity is always being applied, even if it is held.
All right, so that's where we need to put that thing I was talking about a second ago. We're simply going to check. If not, so here we are using another logical operator. We're using not, which you guys didn't see a few minutes ago in the lecture, but that's cool. So if not this,
then we apply gravity. So if we're not holding the ball, apply gravity. Otherwise, do apply gravity. So grab, and we can grab it. Because as long as we're holding it, we're not applying gravity.
Now if he just lets it go dead still, gravity's going to pull it straight down. It just has that perfect bounce. There's no dampening going on there.
So, all very well.
All right.
So let's see.
So now we need to get a little bit of a little more sophisticated bounce in there. We need to basically just start reducing our velocity a little bit.
So we need to, I guess what it boils down to is we need a special case bounce for the floor.
Okay.
Because for the sides and all, that's fine if they keep their velocity. We don't have the system's that complicated yet. But whenever we hit the floor, to make the bounce more realistic, what we could do is have, on every floor hit, we slow the ball down some.
So we can just call a procedure like apply bounce or floor bounce or whatever.
Probably apply bounce, because we've got apply gravity, so we'll apply bounce.
Okay.
And we'll block this in. And now, apply bounce. We need to go and, let's see, we need to bleed off velocity every bounce. So when the ball is going down in Y and it hits the floor, it comes back up. We want it to come back up with less velocity. So let's see. Another thing I think I need to do is, since we have a customized bounce, if we go back to the update procedure for a second, down in the Y, if the Y is greater than the client height part. So the first part of the position Y check, we're just reversing the velocity, but we're keeping the actual magnitude the same.
Right.
So that's not going to work here since we're about to do almost the same thing in apply bounce. So I'm going to take this out and instead call the apply bounce from here. So apply bounce.
So you notice he's only worried about if it hits the floor. If it hits the ceiling, we don't care.
Right. I mean, we could maybe change it around so that it applies to all, but for now the floor will work.
Yeah.
So it's almost like an apply special bounce or apply floor bounce. So back in apply bounce, we do need it to reverse, but instead of being -1, it needs to be times something less than 1, so we bleed off some magnitude.
Exactly.
So we can set our velocity y to equal velocity y times negative something.
Yeah.
And in this case,
0.09 will give us...
So minus 0.9 should...
So every bounce is going to be a little less. It's going to lose energy, basically.
And with that, let's see. Do I need to slow down x? Looking at it. Yeah, we might as well. We'll reverse y because y has just bounced. So reverse and bleed off some speed. From velocity x, we can take and simply slow it down in x. So every time it hits a floor...
You don't have to, but I mean, this is going to give us a much more natural looking feel by taking x and slowing it down a little bit.
Right, otherwise it'll look like it has no friction.
Yeah, because it'll be able to go forever.
So times 0.9. You could probably, once we get this finished, play around with it and have this negative as well so that it ricochets the wrong way off the floor. Kind of like backspin.
Right.
That'd be cool. But alright, so we've got our velocity slowing down, and if we run it, we should be able to see this actually getting applied. So there's our bounce, slower, lower, lower, lower. Now there is no end condition set, so it'll just sit there and slide. Let's see, what's our velocities?
Right now it's 0.53.
Which might be getting back into the whole subpixel thing.
Yeah.
Now, if we wanted to set up a case to where it stopped sooner, or we had a very controlled case where we can say exactly when it stops, we can do an if, check the velocities, and decide how slow means stopped, and then just go ahead and stop the ball.
Right.
So we'll begin an if and say that if the velocity x, now here we'll have to do something interesting to that as well, with the, or rather velocity y. So if we're checking velocity y, we need to see how slow the ball is going. Now we can't check for an absolute value because it goes +1 and -1 would be the same thing, the same speed. It's a different direction, but the same overall speed. We need to take the absolute of that.
Right.
So that way a +2, say, and a -2 is still a velocity of 2.
Right.
So let's say the absolute velocity in y, and if that drops below 1, then we need to stop the ball. So I'll do a begin
and we'll just set our velocity x and y both to 0.
And we're setting x here as well because if we don't, the ball can slide. So it's like it tries to stop, but it slides instead. So we'll stop the ball completely by setting both velocity x and velocity y to 0.
Okay.
So now, watching for a stop, and...
stopped. And you can confirm this by looking at the ball's velocity up top. Oh, it's still got a 1 on there.
I'm not sure if that's just because of last update or what. I was noticing that actually in the demo version. As soon as we grab it, it gets stopped.
Gotcha. Okay, well, it's just, I guess, the last update on that thing. But it is indeed working. You can see it stopped and the ball velocity is not changing. So cool.
So that, let's see.
You guys can fix that.
All right, I'm trying to think, is there anything else we need to add now that we've got bounce in place? Because we've got gravity and specialized bounce. Let's see. No, I think that's it.
I think that's everything we set out to do at the beginning.
Now we could do weird stuff like this. On a special floor bounce, have X reverse.
Woo, woo.
So it's like this heavy backspin on the ball.
All right, go ahead and set it back positive, run it again, play with it for a second, and I'll wrap things up. And, of course, you still have the ability to grab and throw. So go ahead and throw around, and there you go.
The only thing I think I will do in closing this up is I want to go and rearrange these procedures, because right now everything got created in a kind of haphazard, sometimes alphabetical order. And
You're wanting form events together and custom procedures together.
Group form events at the bottom. So we have things like apply bounce, apply gravity, that's fine. Calculate the mouse velocity, and I want all of that to go along with update ball. So I'm going to take the whole update ball procedure and move it to the section right below calculate velocity. Like so. So now we've got apply bounce, apply gravity, calculate mouse velocity, and update ball. And then after that we have our form create for initializing stuff. We have our mouse down, our mouse up, and our timer.
All events, basically. Well, ladies and gentlemen, that's pretty much going to wrap up this video. The whole idea was to introduce you to the if statement, even though I know you've seen it before. As I said at the beginning of this lesson, we have never had a dedicated lesson covering the use of the if statement. Now we've looked at it. We looked at using the if-then statement with a single statement being executed if it was a true. We took a look at executing compound statements. We took a look at if-then-else and how to set that up. And then we took a look at and we took a look at or, and we even squeezed in a quick look at not. We also squeezed in a quick look at else if. Those we just kind of snuck in on you. Very, very easy to use. I mean, we've already demonstrated them now. And then we put together this simple application that's just fun to play with. Now, some of you guys get creative. Let me see some neat things posted over on 3D Buzz with where you've taken some of this code and made it a bit more interesting, because there's a lot of things you can do now. You guys now know how to do simple collision detection. You now know how to work with velocities and add things like gravity, and as Logan was showing you, a simulated backspin. Make some interesting stuff. Impress me. Show me that these videos are really being put to good use and that you guys are getting something out of it. I'm really excited to see what you guys can turn out. So that's going to wrap up this lesson on the if-then statement. The next lesson is probably going to cover some looping. We'll find out when it pops up, but I'm pretty sure it's going to be some looping. And again, I promise we'll throw in something interesting like we did here. And then after that, we will jump back onto the MP3 player / music practice center and get that wrapped up, because you guys are going to need looping off. As a matter of fact, Logan, thinking about it, we're going to also need one lesson on working with data on a hard drive, writing information and retrieving information.
General I/O, stuff like that.
So, ladies and gentlemen, I hope you guys enjoyed this video and got a lot out of it. And until next time, keep programming in Delphi. We'll see you guys.